So in this video, we're going to take a look at the next three questions from the practice test. The first question, problem 4, we're told that there are 3x minus 2 trees planted in each row of a rectangular parcel of land, and that there are a total of 24x minus 16 trees in the entire parcel. And what we want to find is how many rows are there in this parcel. So kind of a weird problem, always helps to draw a picture. We have a parcel of land and it has trees, which I very eloquently represented by dots. We know that in each row, there are 3x minus 2 trees. In addition, we know that if we counted the total number of trees in this plot, that it's 24x minus 16. Well, how would we relate the number of trees per row to the total number of trees? Well, what if there were, I don't know, like 5 trees in a row? I drew it as 4 there, but what if there were 5? And what if there were 4 rows? You'd multiply the number of trees in a row times the number of rows. And that's exactly what this is saying here. We know that total trees is trees per rows times number of rows. We were given an expression for total trees, given an expression for trees per row, and we want to find the total number of rows. So let's kind of match this up with respect to what we were given. We know that the total number of trees as a function of x was 24x minus 16. That's equal to the number of rows, which we don't know, call it r, multiplied by the number of trees per row, which we can call 3x minus 2. So we want to find what number we need to multiply 3x minus 2 by in order to get 24x minus 16. Well, this number is multiplied by this binomial, and the way we do that multiplication is by distribution. So whatever this number is, when you multiply it by 3x, you have to get 24x. And when you multiply it by minus 2, you have to get minus 16. So what number when you multiply by minus 2 do you get minus 16? That's 8. What number when you multiply 3x do you multiply 3x by to get 24x? That's 8 as well, not surprisingly. So the answer here is that there are in fact 8 rows, which is answer D. So let's look at number 5. A little bit of a confusing question. We'll read it here. We're told that 18 people order a soup or sandwich for lunch, that each person in the group has only one or the other, that sandwiches cost $7.75, and that soups cost $4.50. We know that there were 18 total lunches ordered, and then it cost $113.50. And what we want to find out is how many sandwiches were ordered. So it's a lot to digest there, but let's start off by writing what we were given. We know that there are 18 total people, that each sandwich cost $7.75, that each soup cost $4.50, and that all people had soup or sandwiches, and that the total cost was $113.50. So really what we want to find is, if you go back to the actual question, how many people had sandwiches. But we really don't know how many people had sandwiches or how many people had soup. So let's actually make those our variables. Let's make the number of people that had soup S and the number of people that had sandwiches W. What do we know about S and W? We know that since everyone ate one or the other, that if you add them, you get 18. Because there were 18 total people. So the number of people that ate soup plus the number of people that ate sandwiches was 18. In addition, we know that each cup of soup we bought cost $4.50. Each sandwich that we bought cost $7.75. And that in addition, right, that linear combination of the sum of those two things is going to be $113.50. So really what we're able to do is to write two linear equations in two variables. So now it's just a matter of being able to solve those two things. So how do we actually do that? Well, the approach that we talked about in our actual refresher class was to solve via elimination. So how would we solve these by elimination? We have 7 plus W equals 18, 450S plus 775W equals 113.50, hard to read. Wouldn't it be nice if this number in front of S was minus 4? Minus 450, I should say. Then when we added the two equations, the s's would just go away. So that's what I'm going to do first. I'm going to multiply both sides of equation 1 by minus 450. And don't forget, you're multiplying the entire left side of the equation and the entire right side of the equation. So when you multiply the left side, minus 450 times quantity, S plus W, we're going to do a distribution. We're going to get minus 450S minus 450W. And on the right side, minus 450 times 18 is just going to be minus 81. So I have a different form of that first equation that now I can now write over top. If you notice, I just rewrote equation 1 directly over top of equation 2. And then if I add those two equations together, by design, the S terms are going to go away. How many W's do I have left? Well, minus 450 plus 775W is just going to be 325W. And I have a little bit of a typo here. These should both be positive. I will rewrite that. Sorry, I was trying to rush and write these this morning. But the answer actually comes out the same. If you solve for W, you get that W is equal to 10. And then by definition, if there were 10 sandwiches and in total there were 18 sandwiches and soup, there would be 8 soup available. So the answer there is that there are 10 sandwiches, and that is answer D. So finally, we'll look at question 6, which is which of the following has both 1 and 3 as solutions, and we're given a set of quadratic equations or second-order polynomials. They both have x raised to the second power. So remember that if these values are solutions to this equation, then when we plug the values in for x, the left side will equal the right side. So if you know how to solve quadratic equations, feel free to do so. You can either solve them by factoring, or you can solve them by using the quadratic equation. However, if you're a little rusty on that and you just want to try to see which of these four these values are solutions to, you can just take and plug in these values for x and see which equation is satisfied by both of these values. So basically what I'm going to do is go one by one, plug in x equals 1, plug in x equals minus 3, and once I find one that it works for both of those values, I'm actually done. So here, x squared minus 2x minus 3 was option A. I'm going to check it when x is equal to 1. If I plug in a 1, I get 1 squared minus 2 times 1 minus 3, and what I'm asking is that equal to 0? So if this checks out, then 1 is a solution to this equation, and I'll move on and check negative 3. So let's do the arithmetic. 1 minus 2 minus 3, that's going to be minus 4. That is not equal to 0. So 1 is not a solution of the actual equation A. So clearly it can't be the answer to this problem. Even 1 didn't work. So right away we can move on to B. X squared plus 2x minus 3 equals 0. Let's check number 1. If you plug in a 1, 1 squared plus 2 times 1 minus 3, do your arithmetic. You'll get 1 plus 2 minus 3. 3 minus 3, that is equal to 0, so 1 is a solution. Now let's check minus 3. If you plug in minus 3, when you square you get a for x squared, we plug in the minus 3. For x, we plug in the minus 3, do the arithmetic. Minus 3 squared is 9. 2 times minus 3 is plus minus 6, or just minus 6. We have another minus 3 here, so let's do our arithmetic. 9 minus 6 minus 3 is actually 0. 0 equals 0. So not only was 1 a solution to this equation, but so was minus 3. So since this equation is satisfied by both 1 and minus 3, then that is the actual answer. So equation B is the equation that has the solutions 1 and minus 3. So you don't have to check anymore. Again, that might not be the most efficient way to do that. If you know how to solve quadratic equations, feel free to approach it in that way.